Okay, so let's go and begin today's webinar. So today webinar is going to be all about a discussion of the Hadoop platform and basically taking a scale of when to use Hadoop and the primary applications where Hadoop can be used better. So next 1 hour it's going to be a very interesting debate on Hadoop technology and seeing some use cases of Hadoop. So with this, let's go and begin today's webinar. So before even going and understanding now what about Hadoop, etc., I just like give a very small introduction of what is Hadoop. Okay, that helps you a lot. So since we have only 1 hour of time with us, so the first 30 to 40 minutes I might go over the theoretical aspect of the webinar, and the last 20 minutes I like to cover some of the use cases with Hadoop where primarily Hadoop can be used very much effectively. Okay. So maybe I can give a very small introduction on Hadoop even before starting what is the session is all about. So let me give a very small introduction of basically what Hadoop and why Hadoop is all about. So Hadoop is closely related to the big data domain, right? So that everybody is already aware of why we use Hadoop, because the primary intention of using Hadoop is because it is totally a framework which is used for big data domain. So prior to Hadoop, right? So what makes Hadoop one of the most important framework in the market today? That is the answer we need to understand first, even before understanding when to use Hadoop or when to not use Hadoop. So the primary thing of anybody has to understand is why Hadoop, right? How come Hadoop become a very important perspective in the big data domain today? So to answer this question, so primarily what happens was, as big data means a big data is nothing, lots of data, right? As as we start accumulating more and more data, right? We started facing problems like the first thing, the data storage. So how effectively the data storage is going to happen, and also on the data analysis. So a typical RDBMS developer, I hope everybody can able to see the notepad, right? I just shared a notepad. Okay, yeah. So so before as we are discussing of why Hadoop, so as the data gets progress to a, means as an organization, when I might have started with a storage of 20 GB of data, right? So as my organization grows and the data capacity also grows along with the organization, right? So in that case, what happens? So we need an answer for this, right? As as the data keeps growing, is there any system can accommodate how much data is going to come? So I can't define. It might be a 40 TB of data, or down the line it might go to 100 TB of data. Down the line it might go to 150 TB of data. Nobody is in a position to define, right? So that's what the problem started, right? A typical RDBMS cannot solve this problem because an RDBMS is fixed. We are talking about something called as totally and absolutely figure which we cannot come up. It might go to 500 dB, it might go to 600 dB, right? So that's the one problem. And next is the data analysis. So when we talk on the analysis perspective, so is it possible to take the complete 100 TB as an input? Right, so this is what the next question comes up, which I am never able to achieve with my current database problems, right? In the current database I cannot do this, or in current solution, it may be any solution, not only a database perspective, right? Can I consider the complete 100 TB as an input, or can I consider the complete whatever the data I'm going to use as an input? If I say X amount of data, okay, so finally the bottom line is the big data put a very simple problem is, if that is an X amount of data, so can you store this X, and also can you do the complete analysis on X, right? So this was the biggest challenge, right? This is the challenge which was put forward to the complete industry. So that's what big data started creating the problem. The primary reason is the database cannot scale up. There's a limitation of every single person is who are using the database is clearly aware of why it cannot handle 100 TB, and we don't want to discuss on that also because that's not the primary reason of using this, correct? Okay, so So in order to answer this, so we come up with a framework called as Hadoop. So that's where basically Hadoop came up in the picture. So it complete distributed data set. So that's the solution Hadoop came up, a complete distributed data set. So that's what basically Hadoop started discussing on it. So let's see maybe a internal understanding of how Hadoop is going to solve this. But this is what Hadoop was trying to solve. Okay, and this is what Hadoop has solved, and that is why we are using Hadoop. It gave us an answer of storing any amount of data at the same time of storing at the same time of doing analysis to any amount of data. Right, there is no such thing like restrictions. There is no certain restrictions on the big data technologies with Hadoop, right? And how it is achieved, let's see in today's session, right? So that's what I want to put forward first. What basically Hadoop is trying to solve, right? So it is a distributed framework, a completely distributed framework which tries to solve the big data problem, the problem which we discussed called as amount of data and as well as a complete analysis of data. Okay. So that gives a very small introduction of what Hadoop is all about. So maybe next we can go over the slides and understand when to use Hadoop and when not to use Hadoop. Okay. Is everybody clear on this? You're getting an understanding of what Hadoop is all about? Okay, fine. So okay, so as we discussed, so that's what basically Hadoop is all about, etc. Everything is fine. So the one important thing everybody has to understand today, what they think is that because Hadoop as a framework is able to solve all the problems, right? So it's not something we should use Hadoop for everything. Okay, because we have a solution like a framework called Hadoop, which can solve the distributed processing of data, right? So we should not conclude something like Hadoop is the solution for everything. So that's not the case, right? There are some scenarios you should not use Hadoop, and there are some scenarios you should use Hadoop, right? So let's consider. So now let's coming back to this relations when to use Hadoop. So let's take some of the scenarios when we are going to use Hadoop. So similarly, so we are going to use Hadoop as we already discussed. The primary reason of using Hadoop is whenever the data size is expected to be very huge, right? Where the data is going to be exponentially growing. And you can also perform data analysis on anything. It means you can perform the data analysis on structured and the semi-structured and unstructured. Basically, you can do a data analysis on anything, right? And also for future planning of data. So for example, if your organization is having 10 TB of data and you are expected to grow to a very greater extent, right? So Hadoop is a perfect solution for that because it can scale very much in a very good distributed way. Okay, so let's go back and let's do a small MapReduce example now. Let me show you a small MapReduce example. So technically, I'm going to show you an example of how to process the structured data, and also I'm going to show an example of how to process totally unstructured data. Okay. So meanwhile, I'll take some of the questions. Is there any major changes in Hadoop 1.1 recent releases? There's a complete change. It's not even a major change. There's an absolute complete change. Fine, Ravi. There's a complete change in the releases. Okay, I want to perform dimensional production of images. I'm going to show an example of unstructured data with images, Kashish. So I'm going to show an example. Okay. Apart from prerequisites like Linux, we should have now before starting learning about what is the way to learn it. So Vishal, that's you can always join the Edureka course. We will guide you the exact way of how it can be done. Okay, we will provide you the nice knowledge on basically how to handle most of the things. Fine, Vishal. I just show a very simple MapReduce, then I will go for a very complex way of showing the MapReduce example. Next example, I will take you go through one of the unstructured files of using Hadoop. Okay, so first thing I'm going to use a very simple MapReduce example of showing how easily MapReduce can be done with help of Hadoop. So MapReduce is one of the data analysis algorithm which is coming inbuilt with Hadoop. Okay, it's one of the frameworks. So as I said, you can broadly classify into your Hadoop into three things. So one is something called as data analysis, and one is something called as data storage, and one is something called as your basically data science. Okay, so data storage is something where the data loaded into HDFS, right? So we talk about how to load the data into HDFS, etc., all those kind of things. So data analysis is something where we are going to do some processing of data. So whatever the data you store distributed, you are going to do that. And data science is something where your machine learning algorithm comes up in the picture, like Mahout, etc., rest of the things. Right, so this is where your Mahout, machine learning, and etc., all the things. But the most interesting thing is the Spark can be used in all the three. Okay, Spark is one of the most important features which can run on top of Hadoop, and it can basically solve the problems of all the three in one shot. Okay, so I'm just going to take the processing of data, which basically the initial way of processing data is a MapReduce algorithm. So I'm just going to show you a MapReduce algorithm, how Hadoop runs. I'm just going to give a document to Hadoop and trying to find basically how many words has been repeated. Okay, so once we did with that particular application, next I will take you a completely unstructured data. Maybe we can take some 10 images and try to find which image is duplicated, okay, with the help of your MapReduce algorithm, right? So I'm not going to discuss much on MapReduce algorithm, just maybe I can give a smaller introduction. MapReduce algorithm is just nothing, a concept of mapper and reducer process. So when you say mapper and reducer process, the data will be split parallelly into multiple smaller sections, and each smaller section will be processed separately by a mapper. So once all the mapper has completed its process, the data will be combined and given to the reducer. So reducer is the person who is going to take all the data and process and finally going to produce a result. So for example, in this particular thing, so let me take your distributed file system. So this, sorry. So if you look at this particular data set, right, so it's just a normal data set, which is like a file system inside your Hadoop. So what basically the mapper and reducer does, so I'm telling in a very simple way. So mapper is something which is going to run in parallel. So for example, each and every line can be given to a separate mapper on the least scenario. On the very least scenario, so what are the line you have? You have 5 lines, right? You can ask the mappers to start processing all the 5 lines. So that's why Hadoop is so much powerful. So if you have 5 lines of input, you can start 5 mappers, and all mappers can run parallel. And you can go and means you can go and suggest what your mapper should do, right? So all you have to say is that you have to write a code and tell back what the mapper should do. So that's all as a developer you should say, right? So even if you're going to have some let's consider 1 lakh record, or maybe if you're going to even have some more than a lakh record, right? Even in that kind of scenario, if you look back, you can run any number of mappers you want. Okay, there's nothing much, there's no restriction like you should have only this much number of mappers. Okay, based on the availability, Hadoop can provide how many mappers it can based on the system's availability, etc. So that processing 1 lakh lines or processing a 10,000 lines, instead of processing in a sequence way of going line by line, so Hadoop queries can process everything parallelly. So it can split 100 lines into 10 lines each, and you can start working on 10 lines. So once all the 10 lines has been done, so once all the parallel process has been done, the output will be collected, and given to a final section called reducer, where the final section of the output will be done. So for example, in our particular scenario, each and every word, for example, if you had 5 lines, and each and every line might add a word called hello. So hello might have repeated in each and every line, right? So once all the mapper does this process, the reducer steps up and basically combines all the hello and says, okay, that you have repeated for 3 times. So that's how basically mapper and reducer works. So the mapper takes responsibility of running each and every smaller section of data whereas Redis takes responsibility of combining the mappers and dumping the data. Okay, fine. So where mapper and Redis runs, everything runs as part of your Hadoop cluster. Okay, a cluster is having a master and slaves. So all the mappers and Redis runs on slaves. They run here. Fine, friends. They basically run here. So that's what their primary intention. They're going to run here actually. So if basically, say for example, if I'm going to execute the same job, so let me open up the Hadoop shell and let's execute the same job. So maybe after this example, I can. This is a complete structured data, so very simple operation. The next thing what I'll be basically going on is, after this particular example, I'll just show you the image files. Okay, how the image file works, etc. All the things. So just I'm basically executing some of the basic Hadoop commands so that it makes sure the data is there, etc. All the things. So I'm just making sure the input file and output file, everything is existing. So that's all I'm doing. There's nothing special in this. So let me run the job. Okay, so I'm going to run the job of Hadoop. Since it is a Java program, so everything will be part of a jar file. So I'm just running as a jar file. So just I'm trying to process all the words and I'm trying to find how many times each word has been repeated in the duration. Okay. So the same thing with Spark will finish faster. Okay, it will definitely finish faster compared to this. So that's the advantage of having Spark, because Spark runs everything in memory. Okay. So basically, when you look back and see the sequence of output, so when you go back and see the output now, everything again comes as part of the HDFS file system. Okay, when you see an output, it basically says it has processed the complete data which has been provided. This data can be of any size. That's what the point I'm trying to say. As an example, we have taken only less data. Even though it's going to be a data of any size, it's going to perform in the same way. Okay, because in a typical production system, you have a large cluster which is expected to run faster, right? And it basically tries to tell us each word has repeated how many times. Okay, as simple as that, a very simple algorithm. It's a very simple concept where we are basically running the things parallel, even in storage as well as in processing, right? Maybe the next example, I'm going to show you completely on unstructured data, something called as images, how we are going to process the images. Okay, so Spark is for streaming data. Does it perform well for data which is not live stream? Spark is the only best solution currently we have for live stream caches. The current technologies, the Spark is one of the only best technologies which can perform live streaming. Apart from Spark, nothing can perform live streaming better than Spark. No other technology currently in the industry can perform equivalent to Spark, and no other technology is having a growth equivalent to Spark. Fine, Kashish. So it will perform. Okay. So going back to the slide again, and so another usage of the reason for using Hadoop, yes, it can be used along with multiple frameworks. So it can be used with Spark, it can be used with Python, it can be used with MongoDB, etc. It generally can be used with lot of things, right? Okay, right. And so one more thing, Hadoop itself is having something called as internal SQL query tools like Hive, etc. Okay, so Hadoop basically uses a query-based technology, something called Hive. Hive is the most popular wise SQL query-based which we have. And again, as I said, that there is something called Spark SQL, but Spark SQL is something again going to run on top of Hive. Okay, and so once the moment you join the course, we'll be taking you all these things, what basically an Hive query, etc., all those kind of things. Okay, if you are using the SQL table as input file, in what format is the MapReduce perform? So if you are using an SQL table as input file, Sridhar, we have something called scoop. Scoop takes responsibility of transferring the SQL table data into HDFS. So from there, MapReduce picks up. Fine, Shreya? That's the thing. Difference between Spark and SAP are completely different, Jayaprakash. Spark is something which can be used along with Spark can be used for normal processing. Spark can be used for streaming. Spark can be Spark is something can be used for machine learning. Spark is totally different. It's not in a smaller perspective. Okay. But Hive does not handle unstructured data. So yes, unstructured data I'm going to show you, Kashish. As I said, I'm going to show an example of unstructured data. Okay. Hive or Pig cannot handle unstructured data. Okay. If you want to handle unstructured data, you must only use MapReduce. There is no other option. Okay. Yeah. What's the use of a Flume? Flume is again one of the technologies which came before than Spark, means for processing live streaming of data. In our course, we cover Flume too. We'll have a concept on Flume telling you how the live streaming of data can be performed with Flume. Okay. So, about Storm compared to Spark, nothing much. Only one thing I can say: Storm is more matured in streaming. Spark is definitely fastest growing technology, but Storm is more mature in streaming. But Storm is only supported for streaming, and Spark can be used across everywhere. Okay. Spark is better than Flume in processing live streaming. So to everybody, I think there are a lot of questions coming on Spark. So what I suggest is, one thing I can tell you all is that Spark is the better in everything. You can't compare anything with Spark because this is the one of the fastest growing technologies in the world. And for more questions of Spark, I request all you to go to the Spark webinar on the same. We have a separate Spark webinar. You can request the support team about Spark. Okay, so please okay, so please verify with the support team, they'll understand. But definitely there is no comparison with Spark. Spark is always the best better framework compared to everything.